Hey, welcome to Engineer's Workshop. Apologize for the glasses. I was chipping branches and got some real thorny, viney stuff in there that came over and grabbed my face and my glasses and ripped them off my face. So got to get a new set, but I thought I'd bring you something a little interesting. If you've watched in the last couple weeks, Adam Booth had a two-part series on machining a part for a Walker-Turner radial arm drill, and he did this for Tabb of Crosscut Vintage Designs. Look familiar? I just happen to have one of these radial arm drills, and I thought that you'd be interested in seeing it, but I wanted to start by commenting on this piece, this ductile iron piece. It's 6 1/4 inches in diameter and 7/8 of an inch thick. And Adam, over the course of 2 videos, did a series on duplicating one of these because Tabb, when he was taking his machine apart, he didn't realize this machine was, or excuse me, this piece was a separate piece. Fell on the floor, and being ironed, it broke. It's probably gray cast iron. Adam made the replacement out of ductile iron. But when you look at this piece, you know, Adam went through, I don't know, about 3 or 4 different setups. He put a chunk in the lathe, he faced it off, he took the diameter down to 6 1/4, and then he took it over to a bandsaw, cut it off, put it back in the lathe, faced it to thickness, used a trepanning tool to put this groove in the face of it. And then he went over to the milling machine, drilled it, bored it, put it on a rotary table, machined these, they're about 120-degree slots for the fasteners, and then he finished putting in these systems. So, I mean, you know, a lot of operations in this. Screws in the back. And I look at this and I tell myself, I could not design a more perfect part to be made on the K&T Rotary Head mill in virtually one setup. I mean, if it weren't for the fact that this had counterbored holes on the backside to hold it to the face of the ram, you could make this piece without even flipping it over. And let me show you how I would do it. First of all, you can start off from McMaster Carr. They have discs available in ductile iron. You can get a 7-inch disc, 1 inch thick. And I would put a 1/2 inch aluminum sacrificial bed plate on my table with a hole in it. And I'd put a center hole in this. I could do that with the K&T. Bolt it down to the bed plate. And then I would machine the face of this, clean it up because I'm sure it's saw cut, switch over to a couple of toe clamps, and just clean that all the way up to the down to the hole. Flip it over, bolt it back down, and then I could take this thing down to its thickness. With the bolt hole in the center, you can do a couple of things. You can machine the OD, or you could use your toe clamps and you could bore this center hole out to 1 inch, and then using a dowel or just a fixture pin that you make, you relocate the disc on your aluminum bed plate. You can machine right into your aluminum bed plate, so you always have a center to return to. But the K&T could walk that OD down to 6 1/4. K&T could then machine the groove, the continuous groove. Then you can switch over and do a plunge cut through in 2 locations and do your slots. And then I think the only features you have left are locating pinholes, and you've got a counterbored hole that's in from the back. So what you would have to do is, using that locating pin, flip the piece over, finish out those counterbored holes from the back. But I'll tell you, maybe I couldn't do it in 1/3 of the time because I'm not a lifelong machinist, but I bet you Adam could have done this in 1/3 of the time with a K&T Rotary Head mill. and not have to take it from machine to machine. Everything in one operation, one setup. So let me show you the Walker Turner and then how this piece goes on the face of the Walker Turner ram. And I'll show you a Walker Turner radial arm saw, which is a cousin machine to this radial arm drill. Let's go over to the end of the shop here. Wanted to mention this radial arm drill came from Doozer's shop. Doozer's shop and used equipment emporium. He seems to be able to, buy one machine for himself and one machine to sell. So, there's always opportunities to get equipment from Doozer. He's rotating equipment, making swaps, getting this new and having to make space by getting rid of this. So the radial arm drill was really cool because it's almost identical. In fact, there's a lot of identical components to the radial arm saw that we have back up in Virginia. And Doozer has a nice forklift with 6-foot forks to put this thing right over the tailgate and into the bed of the pickup truck. And it was a very easy peasy type of load, only about 700 pounds into the bed of the truck, and it made the trip up to Virginia no problems. On my end, it was a pretty simple matter of getting the straps hooked up to the Yale 3-ton hoist, getting it up out of the bed, and then just driving out from underneath it and lowering it to the floor. So that all went without a hitch. Here's a Walker Turner drill in all its paint peeling and rusty glory. This is, I don't know if this is original paint. There's actually a couple of colors under here. But for being so rough looking, it's basically complete. We have the side panel. Doozer had all of the motor and other loose parts stored inside the base, so I have that leaned up on the other side somewhere here. But you can see that you have control of all aspects. You've got a lifting, elevating crank that lifts the column. You've got the ability to pivot the column anywhere on the table. The ram, let's call it, moves in and out. And this moves in and out on a set of V-gibs, but not with fitted dovetail slides. It has a roller bearing on two sides here, front and back, both sides of the head. Now, one of the things you'll notice is there's a stop fitted on what looks like a unistrut here, but on the head itself, the stop post is on the wrong side, so someone actually has this ram run in the backwards way. The ram has to be taken out, spun around, and brought in from the other side, and then this stop post will land in between your stops here. This isn't so much useful for drilling as it is for operations when this is configured as a radial arm saw. I'll show you its cousin in the other shop here. So we've got up and down, we've got rotation, we've got in and out. Of course, we got the quill travel. And then the other axis we have is the ability to pivot the head. And you'll notice that's where that piece goes, right in there. And you can lock the head at any angle. And there's another lock on this side. And I believe this is a quill lock. Yeah, that locked the quill in place. Spring return right over here. Motor adjustment bracket on the back side with a 4-belt sheave. And there's a 4-belt sheave inside here. Let me bring you around. So we've got a 4-belt sheave, 4 speeds, 1, 2, 3, 4 of the jack shaft to the head, 4 more from the jack shaft to the motor, so a total of 16 speeds altogether. Someone did a real nice job on this table of never drilling into it, which, happy to say, now there is a kind of a sloppy braze repair. This was chunked out on the perimeter coolant trough. There's a big section here that was broken off, but they didn't lose it. They brazed it back on. It's just not real smooth. This is a lock that goes on the back side of the column, so you can actually lock the column in place with this. And that about covers it for the Walker-Turner radial drill and all its features. This is my son's project, not my machine. He is going to restore this and probably make it look just like the radial arm saw, which he also claims possession of. You recall a couple videos ago about how I had two machines brought to the shop, and they were dumped out of the bed of my buddy's pickup truck somewhere between Charlotte, North Carolina, or South Carolina, and Richmond. And so I got this up from Doozer's shop without incident, and I unloaded it with the overhead trolley beam without incident. But then I almost dumped the thing over here, just moving it into this position with the boom pole of my tractor. This is not particularly heavy. I'd say maybe 700 pounds. But I did what I would call a really rookie mistake. I was trying to be quick about it, and I had one lift chain that I had slung up to the boom pole, and I had it around the table like this, and I had the other end up around the other side of the table, and I thought everything was fine, but the way this saw is, it's kind of tail heavy, and so I lifted it up, and of course what happened with the chains? Well, the chain started out in this position, and then I'm inching this thing forward, and before I know it, the chains did that. They slid on the cast iron, and then this thing was tilted back at like more than a 45-degree angle, and worse yet, one chain was starting to come out. If I set it down, it would have went down on its back. So I had to hurry up and get the floor jack out and I think a piece of firewood on top of it. And I jacked against the back of this, and I managed to pick it up to where when I wanted to set it down with the boom pole, it went back down upright. Then I re-slung it with straps and got it to where the straps wouldn't slide, and was able to successfully move it into this temporary resting place without actually dumping it over. But rookie mistake, don't use chains on equipment without having a positive way for the chain to not slip, because steel against cast iron, very slippery. While this is off, I figured we'd take a look at the system they got inside here. So we have ball bearings supporting the bottom and the V's. Here's a clamp system that grabs the outside edges of the of the ram, and the column has I think it's just a plain bearing up at the top, but we're going to spin this around and put the in fact, this clamp is also backwards. So what we're going to do is we're going to reverse this. Let's clean this up while we got it out. physically prevents you from pulling the ram out of the casting. There's one feature on this that Adam did not show you, and to my knowledge he did not duplicate, and that is a vernier scale that goes from 60 to 0 to 60. So this drill can actually be taken 60 degrees off of vertical in either direction. And there's a little pointer on the drill itself I'll show you in a minute, but that vernier scale is engraved into the perimeter of this part. So from this is the side that you see when you look at the face of the ram. And there are low head cap screws. These aren't conventional low heads. The low heads typically have a small hex on them. This looks almost like the same size hex that would be in, I think these are 1/2 inch fasteners. They're certainly bigger than 3/8. They might be 7/16. But I imagine that's also 1/2 inch. But these retain this plate onto the face of the ram. And it is located by the 2 projecting dowels. Now you have to get it oriented so that this scale is on the left side, so this is the top. Now from the back, they've got these square head screws that ride in those 2 slots. And there's actually a shoulder on both the ID and the OD of this slot, and then the center portion is relieved. This surface here is as cast, and then this is the actual bearing surfaces where those screws grab from the back. I don't know that that's necessary. I mean, if you're machining this, you might as well just machine this whole surface flat, but that can go right up to there, over to here. So let's put this back together, put the drill head back on, and you'll see how everything goes together. So I've got the face of the ram cleaned up. It's machined. It looks like it's cut and faced with a pretty large diameter cutter. It's got a 1-inch pilot. And we're going to be orienting this with the scale to our left. And that basically pops right in there. You know what I forgot to do? Of course you do. I forgot to put the 2 square head screws in there. And when you have everything together, the heads of these screws sit about 40 thousandths below this surface. Now the interesting thing is going to be getting these screws to go through the two holes on the back side of the drill head while you get this post indexed in a close-fitting hole in the back side of the drill. Let's figure out how we're going to do that. I think the only way I'm going to be able to do this is to try to put the drill head on at a 60-degree angle and stick one of these screws up in the upper position with some grease. Otherwise, all three of those have to get kind of started at the same time. And I am not that strong to hold this for very long. So let's prevent the drill from turning. Here is the vernier. Now this can be slid up and down. I'm going to put it on 0 to the best that I can see. But there's what the finished system looks like. And we've got the stops that I think serve a better purpose on the radial arm saw, which I will show you next. I had a glitch and lost some audio here, but this radial saw, the Walker Turner radial saw, was actually the first big piece of equipment that I bought. And it was a 3-phase piece of equipment. Luckily, it had a static phase converter mounted onto the back side of it. It was just a box with a starting capacitor and then a potential relay that would pull the starting capacitor out of the circuit, and then the motor would run on single phase after it started up. It's a 3 horsepower motor, 3,600 RPM, but I'll explain later how the saw is actually gear driven. When I got the saw, it did not have a table at all. It was just the base and the upper part of the saw, and you can see that the casting and the ram is exactly the same, except this ram has its adjustment face in a horizontal plane to carry the yoke and the motor, whereas the radial arm drill has that adjustment plane in the vertical plane. I also made some outriggers with casters on this saw so that I could roll it around. Can't really see it, but it is on these outriggers. Also made the outriggers with casters, and I can, it's actually, I think, suspended right now that you can move the saw back and forth on steel casters, which is kind of handy when you don't have a lot of room in your shop like I do. So anyway, I had to make this table and had to make a lot of decisions about where to put the fence because I wanted to get a good cross-cut capacity, and I also wanted to be able to rip to the center of a sheet of plywood, 24 inches. So the outrigger supports bolted onto the side of the top table casting. I bolted those on. I made those out of maple, or excuse me, I made them out of oak. And I actually used the motor to machine those tops of those castings flat. So basically, if you loosen this, you can lift this dovetail key here. It's like a tapered key. And this will let you lock the arm with the saw out. This is called an outrip. An outrip is when you're putting wood through the saw this way and you're making a cut along the length. And for this, what I would do is put the auxiliary fence here. I would take out this fence. This rear half of the table is 1 foot wide, and I would put the fence on the back side of this. And then from that to the maximum outward position of the blade, I think I have I've got probably about 30 inches of movement. The other operation that you may do is called an in-rip. And for an in-rip, I don't know if we can do it with all of the dust collection that my son has attached. I guess we can. An in-rip would lock the motor facing inward, and you would feed through in this direction, always into the rotation of the blade, and you can rip very narrow pieces. Now you can see there's another scale here for beveling the motor. There's another handle here. If I loosen this, and there's another set of V-grooves that would lock this from 0, 45, and actually if you elevate the entire arm assembly, you can point this arbor straight down, and I've done that, and I've used a milling cutter to make raised panels. This is a very, very heavy saw assembly. So the normal operation is a crosscut, and with the dimensions of the table I set up, I can crosscut up to 12 inches on a 45 and up to about 15 inches for a straight 90 crosscut. So it's a very versatile saw, very heavy. You can lock the travel at any point with this knob. Lowering this knob lets you pivot the head, and it has an elevating crank just like the radial arm drill right here. So this is basically as condition it was in as I bought it. I don't know if the paint's original, but it really wasn't very rusty, not at all like the one in the other building, but it's pretty neat. I've also seen this tool set up as I'll just call it a radial arm tapper. And the configuration, like the drill press, it had a tapping head on it. Now, I don't know if that was something that came from Walker Turner that way, or if it was set up specifically by the machine shop that had it. And I wish I had a picture of it. But another thing that you'll notice, the head on the saw version has the face here where the pivot horizontal to the table. And the arm for the radial arm drill has that pivot face on the front face of it. So 90 degrees different configuration from the saw to the radial arm drill. Being a woodworking piece of equipment, this is not a very quiet saw. hard maple table leg. Here's the piece that came off. It's a 12-inch blade running on a 3/4 inch arbor. Normally 12-inch blades have 1-inch arbors, but this saw being from the 50s, it was a 3/4 inch arbor. Another thing that you'll notice, if you look at the center line of the motor, is that the blade, the spindle is actually offset. This is a geared head radial arm saw. We have a drive gear on the top, and it's about a 3-to-2 ratio. The drive gear is, I'm sorry, the drive gear is smaller than the driven gear, and this brings the saw RPM down to about 3,000 from a 3,600 RPM motor. Cast iron guard, auxiliary dust collection, anti-kickback, also cast iron on the back side. You adjust that down to the to skim over top of the wood, and these anti-reversing pawls will lock if it tries to kick the blade back, and it will prevent the blade, excuse me, it'll prevent the work from getting shot out the back. Very positive stops, great piece of equipment. Well, I hope you enjoyed that peek at the Walker-Turner radial arm drill and the Walker-Turner radial arm saw, and the alternative machining method for that rotatable index plate that holds the drill head onto the ram. If you wanted to check out where that was going, it's gentleman's name is Tabb, Crosscut Vintage Designs. He's a woodworker. It comes highly recommended by Adam Booth. So being a woodworker myself, I'm going to subscribe to him and check out his channel. So that's all I had for Engineers Workshop for this week. Hope to be coming to you again soon with some more machining videos and some upcoming projects. Got a lot of things that are stacking up after the winter that I want to try to get accomplished this season. So some electrical stuff, mechanical stuff, upgrades to the K&T, and more new equipment. So catch you next time on Engineers Workshop. Thank you for all the likes and subscribes. Catch you next time.